So here is my electronic metronome. You can see the LEDs oscillating from left to right, and each time it gets to the green LEDs on the end, you hear a beep. Musicians use metronomes to stay on beat while playing their pieces. Here's an example of a classical mechanical metronome. Here's the schematic for the metronome project. You don't need any PCB boards and you don't need to do any programming to make this. You can see on the bottom left hand side of the screen here is a 555 circuit. Basically it generates a clock pulse that gets sent to each of the 4017 ICs, and these are set up in a cascade mode. This 74HC00 chip are two NAND gates. I didn't have any AND gates at the time, so I used two consecutive NAND gates in order to enable the second 4017 IC. So the first 4017 basically handles lighting up the LEDs in consecutive order from left to right. And once it reaches the end here, it gets disabled and enables the second 4017 IC, and it goes from Q1 through Q7 to light the LEDs going back in the other direction. And once it gets to the end, the Q8 output is going to go back to the initial 4017 IC to restart the whole sequence again. And you can see that the green LEDs are connected to a piezo speaker, so that every time it gets to the green LEDs you hear that beeping sound. One more thing to note is that over here by the clock, the resistors R1 and R2, you can set them as fixed resistors, but I used a potentiometer so that I can vary the clock speed. So the potentiometer replaces both R1 and R2. So here's another look at the circuit. You can see on the bottom left hand side here is where I have the 555 clock. The green wires are coming from the first 4017 IC, which lights the LEDs going from left to right. The yellow wires are from the second 4017 IC, which lights the LEDs going from right to left. And over here I have a sliding potentiometer which allows me to vary the clock speed. So if you like this project, give the video a like and subscribe to the channel.